So this is another problem that has appeared in J advance, and the problem says the total number of distinct x in a closed interval 0 to 1 for which this integral equals to 2x minus 1. Okay, this is also appeared in J advance, and this is a good question, not so good question, but it is, yes, it is a nice question, of course. So let's give it a try, let's solve it. Okay, so we are going to solve this. Now we have to find x in 0 to 1. Okay, so the one thing that hits us when we think of these ideas, so what is so let's first think of if this is of course fx. Okay, this whole thing is fx. I'm calling this whole thing is fx, so this whole thing is actually fx. Okay, so what is f of 0? F of 0, you can see you put 0 here, so this limit becomes 0, and this actually f of 0 equals to 1, that is a positive. Okay, f of 0 equals to 1. Okay, to get a feel, we can write this as t squared 1 plus t to the power 4 dt minus 2x plus f1 equals to 0. This is fx, so f of 0 is 1. What is f of 1? What is f of 1? Okay, that's interesting problem. So f of 1 equals to 0 to 1 t square upon 1 plus t to the power 4 dt, and this is minus 2 and plus 1, this is minus 1. So this is f of 1, and because t is from 0 to 1 and numerator is always less than 1, because t is from 0 to 1 and denominator is greater than 1. So numerator is less than 1 and denominator is greater than 1, is greater than 1. Therefore this whole thing is actually less than 1, and a quantity that is less than 1, and this is minus 1, so this whole, so f of 1 is actually negative. Okay, so f of 0 is positive and f of 1 is negative, so there is at least one root in 0 to 1, that we can say. Why we can say this? Because f of 0 is positive, and of course we can say because this function is also continuous function. So in a continuous function, if let's say f of 0 is positive and f of 1 is negative, it means that the function has intersected x-axis somewhere in between 0 to 1. Okay, so there is at least one root in 0 to 1. That what we can say from just putting the value. But we will analyze this a little bit more to find is there any more solution to this problem or not. So using Leibniz, we shall actually differentiate it. So f dash x would be, I am writing f dash x, it would be x square upon 1 plus x to the power 4, and this would be minus 2. Okay, and this would be minus 2, and so yes, that would be f dash x. Okay, again this quantity is less than 1, so f dash x is always less than 0. Therefore fx is continuously decreasing function. Fx is continuously decreasing function, and f of 0 is 1 and continuously decreasing function, so therefore just one solution, because fx ने 0 से 1 के बीच में बस एक ही बार कट किया है, और वो continuously decreasing function तो एक ही बार कट करेगा, and that would be the solution which we found by this, and this also satisfy our result. Okay, so that's a solution. So therefore there is only one x in between in 0 to 1, so that satisfy this condition. Okay, so that's a beautiful problem. I think that also involves the use of monotonicity, so that's a solution. Okay, let's solve some other problems and see what we can learn from that. So let's jump to new problem. So before solving another question, let me give you one more approach. I don't know whether it's correct or not, because when I solved this problem for the first time, I used that approach, and that's my approach. So I would like to to see comments of yours in the comment box whether it is mathematically accurate or not. I know that it is. Okay, so I'll reply your comment. Okay, so let me solve this question with the approach which I used for the first time. Okay, so this is kind of a function that is given to us. Okay, so without knowing, of course, we have to find something. So the first thing that anyone should do is to find f of 0, and that is 0, and to find f of 1, and that is something is less than 1. Okay, that's very basic, because if you write this as 0 to x t square upon 1 plus to the t to the power 4 dt minus of 2x plus of 1 equals to 0. So f of 1 is something that is less than 1, because this is less than 1. So okay, so that's what the first impression of this problem looks like. But then what I did was I got a differentiation of this function. So using Leibniz I differentiated it, and I got x square upon 1 plus x to the power 4 equals to 2, and or let's say minus 2. Okay, so this was, or let's say equals to 2. So here we can write it as 2x to the power 4 minus x square plus of 2. Okay, that's fx. Okay, now that's our fx. This is to the power 4, so, and this is x square. So that's fx. So, sorry, that's f dash x, because that is f dash x. So this will be minus 2x to the power 4 plus of x square minus of 2, and this will be f dash x. Or we can write f dash x taking minus common, we can multiply it by minus 1, and so I'm just taking minus out for a better understanding, because you have to draw graph and all. So and that's what I did then, and I want you to write in the comment whether it is correct or not. So this is f dash x, and integrate this f dash x. So the integration of this function will give us fx. So fx would be 2 by 5 x to the power 5 minus 1 by 3 x cube plus of 2x. Okay, and fx would be then I will take LCM 15, so this will be 6x to the power 5 minus 5x cube plus of 30x upon 15. Okay, this will be kind of a minus of f of x. This is minus and this is minus, because you will move 30 by minus. So this will be minus of f of x. Okay, now here this is minus of f of x, and this is our f dash of x. Okay, now what we can see from these two equations is that, so here this is f dash x, and we can see that if we assume x square equals to t, then this becomes a minus of 2t square plus of t minus of 2. Okay, and here d is less than 0 and a is also less than 0. So f dash x is always negative. So f dash x is always less than 0. Therefore fx is continuously decreasing. Fx is continuously decreasing. Okay, that's what we can say. And because it is continuously decreasing again, so we have to use these two informations to find that there will be only one x in 0 to 1, 1x only. Okay, so that's how also we can attempt this problem. So that's another method which I used, and I got the right answer. So I don't know whether it is correct or not, but I am asking you to comment. So let's solve another problem, and we shall wrap up. So this is another problem that has been asked in JEE Advanced. So this was also asked in JEE Advanced. So let me point out here. This is also asking 0, and that's very beautiful problem. This is actually very beautiful problem. So in this, when I was solving this, I got the very first, first option right, but I was struggling to find the second option. So, and of course by saying that you can figure it out that two options are right and two options are wrong. So let's see, let's solve it. So I want to write the solution, but first we have to analyze the problem. Here x actually begins from k and it is in between k to k plus 1. Okay, that's the thing. So if the problem says that it is k plus 1 upon x into x plus 1, that's the thing. Okay, so if I put x equals to k here, then this will be actually lesser than, let me write it here, because k x से भी छोटा है, k सबसे छोटी वैल्यू है, k x से भी छोटा है, x की जो सबसे छोटी वैल्यू से भी छोटा है, and therefore डिनोमिनेटर छोटा हो गया, because डिनोमिनेटर छोटा हो गया, so this whole quantity is greater than this quantity, because x is actually greater than k, and I put here and I have substituted k at the place of x. So here denominator बड़ा हो गया, therefore this whole quantity is greater. Here denominator is greater, therefore this whole quantity is lesser. So that's the relation between them. And what I'm doing is I'm just getting this cancel here, and I'm integrating this both side. So I think this is what I says. So this here comes out to be k and dx upon x integral, and this will be k, and this will be sorry, no k, because it is k plus 1 is actually cancelled here. So this is dx upon x, so this will be ln x, and limit would be again from k to k plus 1 as given in the problem. So we'll use that. So we can write this as this. So this is ln k plus 1 minus of ln k, and this was I. So and this is from k equals to 1 to 98. This is this relation. Okay, I'm actually keeping this all here, so I'm not writing it. I took this whole function here. Okay, now just putting the value, we can see that I is less than ln k plus 2. So we'll put 1, so this will be ln 2 plus ln 3 all the way up to ln 99 minus ln 1 minus ln 2 all the way up to minus ln 98. Okay, so this all cancel here because this is 0, so this all cancels here, and what we are left with is just ln 99. So I is less than ln 99. So when I was solving this, I got this first option right, and this is option number C. Okay, but we have to find a relation between these two, whether I is greater than this or lesser than this. So we'll solve it. So let's try that out also. Again, using this property that x is greater than k and less than k plus 1. Okay, this I'm using this. So and again doing the same steps again and again. So this is x into x plus 1, and this, if I put k plus 1 here, just for the sake of it, if I'm putting k plus 1 here, then k plus 1 is actually a greater. Okay, then k plus 1 is actually greater than every possible value of x. Therefore if I'll put k plus 1 here, so this will be let me think it again what to. So yes, so I mean let us try. I don't know whether, so let us try, just let's see what we get. So if we put k plus 1 here, then हम x की सबसे बड़ी वैल्यू पुट करें, जो x की हम जो सबसे बड़ी वैल्यू हो सकती है उससे भी हम बड़ी वैल्यू पुट करें. So because denominator now here, because this denominator is greater, so this will be, I am putting k plus 1 here, so this become k plus 2. So ये denominator छोटी है, so this quantity will be greater, and this denominator is larger, so therefore this quantity will be greater, so lesser, so this will be the sign of inequality. Okay, and let's see. So we'll integrate this again, and this k plus 1 cancels here, and this is dx. So this will be actually I greater than integral dx upon k plus 2. Okay, so I will be greater than 1 upon k plus 2, and here x will put limit to k to k plus 1. This implies that I is greater than, I am not carrying this I greater than always, so this is 1 upon k plus 2. Let me write it more clear, I have a very pathetic handwriting. So this is k plus 1, so this is 1, so this is I. Okay, and this is actually from k equals to 1 to 98. This is 1 upon k plus of 2, so this whole thing expands as 1 by 3 plus 1 by 4 all the way up to 1 by 100. Okay, that's what this I is, I greater than this. Now that's where I was stuck when I was solving this for the first time. So I have a solution for this. So what teacher did was, he did that this whole thing is actually, so I am calling this whole thing is actually greater than this 1 upon 100 plus 1 upon 100 98 times. Okay, let me write this. This is always greater than 1 by 100 plus 1 by 100 up to 98 times. Okay, up to 98 times. So this becomes 98 by 100. So this is greater than 1 by 3 plus 1 by 4 plus all the way up to 1 by 100, and this is less than I. So 98 by 100, we can cancel this out by 49 by 50. Okay, since this is greater than 49 by 50, since let me write it again more. I have a very dull handwriting. So this is 49 by 50. Okay, and because this is greater than 49 by 50, but I is greater than this too, so we can say that I is greater than 49 by 50. Okay, so that's I think we got it right. So option number B is a correct option. So that's, but what we can do also is we can find some relations. Okay, we can find some relations between this 49 by 50 I and ln 99, and I think that is very obvious that from these two inequality we can say that ln 99 is greater than I, and I is greater than 49 by 50. Luckily this option was not given, but this could also be an option. So these two are our answers. I think that's all. We'll solve one more problem and then we'll wrap up in this series of JEE Advanced Compendium. We'll take a lot of questions. We'll actually solve all problems of JEE Advanced of definite integral of last 10 years. So let's solve another one. So this is also a problem that is appeared in JEE Advanced. I think again this is an easy problem, but and again by looking at the limits we can see that it is projecting us to use King's rule. So let's solve it. So, and I'll request the viewers to hold the video and try it by yourself, and then all the solutions. So this is again we'll use King's rule. So we can write I equals to 3 by 2. I am just taking this 3 out. I assume that you all have the basic idea of King's rule. This is 5 by 2, and this is 3 root of cos x, and to this cos x plus of this sin x, and here we shall use, so this is power 5, okay, and using king, then we have to convert this cos, and this will be pi by 2 minus x, so this will be sorry, this 3 will be not here because it is taken outside. This will be root sin x again, and this would be same thing, so cos x plus sin x to the power 5, okay. This whole with dx, okay. So this is 3 by 2, this is 0 to pi by 2, and this both cancels out to be here dx upon root cos x plus root sin x to the power 4, okay. Now we can see that this is a very good combination of cos with power 4. If you will take root cos out, it will be cos square, and this I am taking a root cos out, so this will become 3 by 2, 0 to pi by 2, and this will be, if I'll take root cos out, so cos square will come out here, and this cos square we can write as sec square, so this is sec square x, and here it will be 1 plus under root of tan x, okay, under root of tan x to the power 4, okay. So that's it. So we can write tan x as considering that it's under root, so it is wiser to use tan x equals to t square, then sec square, then sec square x dx equals to 2t dt. So we will put that here, we will put it here, so this becomes 3 by 2, and if tan, this is 0, and if it and tan pi by 2 is a kind of infinite thing, but let's try that. So we can put infinite here for this for the sake of our convenience. So this will become 2t and dt upon 1 plus t the power 4, okay. These two to cancel here, so no, let's not put limit, we shall put limit later because tan is actually causing trouble here, but let's solve it what we are getting. So we'll add plus 1 and minus 1 to see what we are getting. So this will be 3 by 2, and if we will add plus 1, then this will become dt upon 1 plus t to the power 3, and with the negative, this will become t plus 1 to the power 4, okay. So this will become, so we know its integration, it is x to the power minus 3, yeah, so it will be minus 3 plus 1 upon, so yes, so this would be 3, these 2 is actually cancelled here, so here will be 3 times minus 1 by 2 and 1 upon t plus 1, this will be minus 3, so this will be square, okay. This is from 0 to infinity, okay, and minus, and this will be 1 by 3, yes, so minus 1 by 3, so this will become plus, so 1 by 3, and this will be 1 upon t plus 1, and this will be minus 4 plus 1, so this will be 3, and limit would be from again 0 to infinity. So let's put that limit. If we'll put limit infinity, so at infinity this is 1, and at 0, and at infinity this is 0 actually, at infinity this is 0, and at 0 this is 1, okay, plus 1 by 3. At infinity this is again 0, and at 0 it is 1. So that's the thing. This is 1 by 2, so this is 3 by 2. Okay, and this is 1 by, and this is 3 by 2. This is what, minus 1, because this 3, yes, so this becomes 1 by 2. So oh sorry, that the thing is not visible here. I think this is clear till here. So, and this is 3 by 2, and this 1 by, and this is minus 1 by 3, and this minus 1 by 3 into 3 becomes let me write it here again. I'm sorry for the trouble I'm causing, but this will be 3 by 2, and this is minus 1, because this 3 goes multiplied with 3 and becomes 1, so this is 1, so this becomes ultimately 1 by 2. So that's the answer. So answer is 1 by 2. 1 by 2 is the answer. Okay, so that's all for today. I shall upload more videos. As I said, that I shall cover all 10 years questions of derivatives of different integrals and so forth, many chapters. So that's all for today. Like, share and subscribe. Thank you.